In this video, we're going to do some more examples of working with limits. Now this first example, if we put in the -7, we're going to end up dividing by 0, which is a problem. But if you'll notice, we can factor this one. And then you'll see the x plus 7's divide out. And now we can plug in the -7 and calculate to get -11. This example, we are going to infinity. And if we plug it in, we have infinity over infinity, which is really hard to figure out. But from previous examples, we know that we could divide by x to the highest power. Well, this is a similar idea, but instead of dividing by x to the power of 2 or 3, we're going to divide everything by e to the x. Now we can simplify. Now just like if you have 1 over x cubed or x squared, as x goes to infinity it goes to 0, same idea here. If you have 1 over e to the x, this will go to 0 as x goes to infinity. So we end up with 2 over 4 or 0.5 for an answer. Here we have a one-sided limit. We're approaching -1 from the left. Now we can just plug in the -1, keeping track of what direction. The top just becomes 1, but the bottom we get 0, and we can't divide by 0. But we can indicate that it would have been 0 approached from the left-hand side, or a very, very small negative number. So we have a positive divided by negative, and this is -infinity for an answer. Now, it never hurts to do a check with these. So you pick a number that's very close to -1, that's on the left-hand side of -1. So in this case, I'm going to plug in -1.001. And this gives us -1002.001. So as you can see, it's a large negative number. And the more zeros you throw into that x value, the larger that number is going to get. So we know -infinity is the correct answer. Now here we're taking the limit as x goes to 0 of ln x. Now this is really just the same as x goes to 0 from above of ln x, because we can't take the ln of a negative number. Now, there's a couple different ways you could do this, but the easiest is if you remember what the graph is doing. It's approaching an asymptote, and it's going to get very large, very negative. So that will be our answer. And again, we can do a check, do ln of 0.001, and we get -6.91. Again, obviously, if you put more zeros in, the larger that negative will be. Now in this example, I'm going to find the derivative of y equals x cubed using our limit definition. Now, using the limit definition, I'm only going to put on an assignment. I will not put this on your test. It is something you need to know. This is the theory behind all the derivatives that you're going to be learning next week. So, dy dx equals the limit as delta x goes to 0, and then it will be our function plus delta x minus our function all over delta x. We need to expand out x plus delta x cubed. Now, I wouldn't expect you to be able to do this expansion in one step. I just did it here in one step to save time and space. So now we can simplify. You'll see the x cubed subtract out, leaving us with And then we can divide out a delta x from every term. And now we can actually plug in the delta x to 0. So this whole term will go to 0, and this whole term will go to 0, leaving us with just 3x squared for our derivative. Now, I use delta x as your textbook does. Some people will use a d or an h instead of delta x. Both are acceptable.